Welcome to Subatomic Tanvi.
Hi everyone. What are you doing?
I read about this particle called the Higgs boson. I'm trying to find one.
Higgs bosons. So they're subatomic particles which are practically invisible, and that's what makes it so difficult for physicists to actually detect them.
So, how do they detect them?
So basically, the way they do it is that they look for specific traces that the Higgs boson leaves behind when it decays into other particles almost instantaneously. And by instantaneously, I mean a trillionth of a second after it's created.
Trillionth of a second. That's faster than I don't know our thoughts. So, how could you possibly measure something that quick?
So basically, again, the way scientists do it is that they collect like an enormous amount of data and analyze that data. And that's how like they can actually look for the specific patterns that it produces when a Higgs boson is noticed.
Okay, you mentioned something about decaying earlier. So, what kind of particles does it decay into?
That's a great question. Let me actually pull up a little chart to explain it. Okay, so here it is. So your question was what kind of particles the Higgs boson decays into. So here's the answer. 58% of the time, the Higgs boson decays into bottom quarks. But bottom quarks produce a lot of background noise. So even though bottom quarks are the most common type of decay, they're not the most useful type of decay. Two other decay channels are used called the 2-photon channel and the 4-lepton channel. So even though these two channels are more rare, they're definitely more useful than the bottom quark decays. So up here we have the Higgs boson at 125 GeV or gigaelectron volts. So they can decay into two Z bosons, 91 GeV each. So I know what you're thinking. Two Z bosons are 91 GeV each. This adds up to 182 GeV, not 125 GeV. How is this possible? So your answer is this is possible because one of the Z bosons exists temporarily as a virtual particle. So it exists just long enough for the decay to happen, then that virtual particle vanishes as well. Just long enough for the decay to happen, which is how two 91 GeV particles add up to one 125 GeV particle. So yeah, that's basically it for the answer.
I think that makes sense. I did wonder about that whole 91 plus 91 equals 182 GeV. So, how
Yeah.
were these masses even calculated?
So basically, at the Large Hadron Collider in 2011, there are two independent detectors, ATLAS and CMS. So ATLAS and CMS reported their findings at CERN again in 2011, but their findings were classified as hints, not discoveries. So for a hint, they would be measured as 3 sigma. So the 2011 hint was measured 3 sigma, which is a 1 in 740 chance of being wrong. And those odds are pretty good, but not so good that they can be classified as a discovery. For a discovery, you need at least a 1 in 3.5 million chance of the finding being wrong, which is a 5 sigma measurement.
That's interesting. So, what was their plan?
So after all this road in 2011, their plan for 2012 was more clear than ever. So what they were planning to do was first to run the Large Hadron Collider at a higher energy to maximize the probability of creating a Higgs boson in the LHC. Then they have to collect like a lot of data and then analyze that data to the core as much as possible. Lastly, they determine whether their findings remain as a hint and just vanish into the vast majority of quantum that we have no idea about, or grow into a 5 sigma discovery, which is always the goal.
Wow. After doing all this work, they would have to hope to see a bump around the 125 GeV mark. Did that ever happen?
So in 2012, again, Atlas and CMS presented their findings at CERN, and surprisingly, both detectors this time presented 5 sigma discoveries of the Higgs boson. So that's always been the dream, and finally it was achieved. So 48 years ago, when Peter Higgs actually thought up this fascinating particle, as of 2012, 48 years ago, he thought it up, and then now 48 years later, Atlas and CMS's hard work finally discovered it. The hunt for the Higgs boson was finally over.
That was a roller coaster ride through the discovery of Higgs boson. Thanks for another awesome episode of Subatomic Tanvi.
You're welcome. Bye, everyone.